Hey, welcome back to Vertical Innovations. I'm Kinsley Jordan, your state director for the UAS Cluster Initiative, and I'm truly excited to bring you this cutting edge technology as we focus on helping technology transfer from research and development into the commercial sector. And as always, these are some of my favorite opportunities to be able to look into the future of capabilities that transfer direct to commercial industry. So without further ado, let's dive straight into it. Now, this technology we're talking about today specifically is an array passive infrared sensor associated processors that can identify and monitor Group 1 UAVs. Now, this is basically a counter unmanned aerial system initially presented by Aaron Cole, chief engineer with NAVSEA. And when we look at this, it's able to identify, as you can see there, with multiple different arrays, Group 1 UAVs. Now, Group 1 UAVs primarily are generally less than 20 pounds, fly above 12 or below 1,200 feet above ground level, and slower than 100 knots. And this passive infrared UAV detection actively addresses the critical challenges of detecting and monitoring small drone threats in sensitive areas. Now, this innovation system uses not only this array of passive infrared cameras, but it also advances and processes algorithms to discreetly identify Group 1 UAVs by analyzing their heat signature, which is incredibly interesting. When you look at that heat signature, its stealth efficiency and adaptability make it an essential tool for securing critical infrastructures and enhancing public safety. Now, of note, the patent for this technology has not yet been issued, but there have been a couple versions of prototypes developed and demonstrated, and the application has already been filed. So when we look at the problem areas specifically that this technology solves, it is the proliferation of small UAVs and drones which possess significant risks to multiple military operations, critical infrastructures, and public safety. Effectively, detecting these threats is essential but challenging due to the limitations of current technologies and environmental capabilities. As we expand upon these, the challenges and of the current solutions, range limitations is one of them. Most detection systems, including RF, radar, and thermal optical technologies, have limited and inconsistent detection ranges, especially in urban areas and cluttered environments. Also, effectiveness against autonomous drones. RF band systems rely on signal exchanges between drones and operators, making them ineffective against fully autonomous drones, which emit RF or no RF signals at all. Also, environmental constraints. RF systems face challenges in environments with high electromagnetic activity, such as airports where frequency management is complex or infeasible. And these environments really truly create constraints that most of the time are very challenging for detective systems. Also, precision identification issues. Radar systems may struggle to distinguish UAVs from non-drone objects, i.e. birds, trees, ground clutter, anything like that. Thermal and visual cameras are prone to false alarms and underperform in low visibility conditions such as darkness, fog, haze, smoke, or low cloud cover, or a cluttered background. And then another problem area, specifically in this space, which this technology is aiming to be able to help fix and solve, is the military and covert operations. Detection technologies like radar can reveal the presence and location of those operators on these covert missions, compromising covertness and sensitive applications. Now, the complex operating environment that these do operate in and military operations or commercial operations take place in, keep in mind that urban settings and other densely populated areas present unique challenges for maintaining consistent and reliable detection across all systems. That's not just in covert operations. Frequency management and interference mitigation are also critical but challenging in high-density RF environments. Essentially, the problem that exists currently out in the market is that existing technologies face significant gaps in range, adaptability, and precision, underscoring the need for improved solutions to secure sensitive areas against UAV threats. And that's exactly why this technology is incredibly interesting as an opportunity to be able to solve just that. Now let's dive into the technology itself. The passive infrared UAV detection technology addresses the critical challenge of detecting small drones that pose risks to privacy, security, and public safety. The system is designed to identify and discriminate objects in real-world environments using multiple different sensors to be able to compare against the background and the foreground. Also, these sensors include real-world environments, being able to detect and discriminate objects through birds, trees, buildings, backgrounds. The system operates using an array of infrared IR sensitive cameras capable of rotating 360 degrees. It utilizes a specially designed IR detector and software system to identify the image signatures of small unmanned aerial systems based on the polarizing light and heat reflected from their engines. This unique signature profile that you can see demonstrated here enables the detection and differentiation of UAVs from other objects within the operating environment. The software component of the system makes it possible to detect and track drones while discriminating and ignoring biological and geological anomalies such as clouds, birds, trees, landscape, and features. And it does this using spatial filtering to identify object size, temporal filtering to track the way that it moves, frame to frame Fourier filtering, evaluating how objects move across and within time periods, change detection to notice the differences in the scenes, polarimetric contrast leveling for signal enhancing and clutter detection, target heading tracking essentially where it has been and where it's going to go, and biological discrimination to ignore birds and other objects within the environment. Overall capabilities of this technology are that it passively and autonomously detects Group 1 and up UAVs at tactically relevant ranges. It's a robust multi-feature filter to reduce false detections, self-collaborating, and with a GUI of object threat marketing, tells the user where the drone is. Finally, range finding. DoD rules are absolutely dependent. By providing capabilities like this, an affordable and efficient scalable solution, the technology is effectively addressing the limitations of traditional UAV detection methods, making it invaluable for applications ranging from military operations to critical infrastructure protection. Knowing that the capability that this offers, let's make our way over to the strengths of the technology. The strengths of this technology, of this capability, include many, many different factors. One is no active radio or radar transmission emissions are required. By relying on infrared technology signatures emitted by the drone, it ensures its discrete operation as a passive capability without interfering with other RF systems, including radios and radar. Second, it enhances detection accuracy. Passive infrared systems are highly sensitive to the heat signatures of UAV motors, enabling precise identification, capable of detecting small Group 1 drones that may evade radar and visual systems. Another capability strength is the portable, compact, and modular design. Its lightweight, compact structure allows for quick setup in different systems and settings, and seamless integration with existing surveillance systems, enhancing scalability for various uses. The low power requirements of this system, designed for energy efficiency, make it suitable for prolonged use in remote and resource-constrained fields, along with an optimized algorithm which employs advanced system processing and real-time analysis for accurate detection, is exactly what systems, military, and civilian defense systems absolutely need with its adaptability. And that adaptability is suitable for a wide range of environments, not only urban settings, but also remote installations. Applications of this commercialization opportunity are vast. Those applications include critical infrastructure protection, military operations, event security, border surveillance, and private property protection. All of these are noted that the importance of the passive detection capability is something much different than is currently offered on the market. Most of the time, systems like this are wanting to be discreet and not noticed, and that passive functionality of what this offers is a huge opportunity. Commercialization opportunities for products are standalone detection systems, compact units for private and commercial use, and also the ability to integrate this surveillance system as a surveillance solution combined with other cameras and RF systems for enhanced security. Services of this capability and market niche would be custom installations, tailored deployments for specific customer needs. This platform is exactly something that would offer that with the passive capability. Strategic partnerships that could be important for the commercial industry and application would be security providers. where they can collaborate with security firms and expand market penetration, or defense contractors who are looking to give the Department of Defense an offering. And this is one of the system capabilities as a passive detection capability, which they could add to their grouping of offering of services and products. When you look at the potential markets, not only is it military, paramilitary security, but also the civilian airport infrastructure and defense infrastructure of the civilian utility capabilities. And that is why, once again, here on Vertical Innovations, we could not be more excited to be able to introduce this capability to you. If you are interested, feel free right now where you're watching this video to go to the PDF that describes more details specifically about the technology itself. Again, thank you so much for joining us here at the UAS Cluster as we bring you real technologies ready to transfer to the market.